This is Sanjeev here. So today we are at our tutorial number 2. So in this tutorial we're going to talk about the geometries, and I'll give you some practical demonstration how to create sphere, box, cone, tube, etc. So I won't cover all the geometries, but I'll cover some of them. And I'll mention all the geometries which are given by Apple. They are default geometries, so I'll mention them in the description link. So if you have any questions, please comment there. So let's start with the practical demonstration. So I'm continuing with our last tutorial. So that is the project we created. Our scene view. That's actually gonna provide me the camera view of the real world. And to run this, as the AR kit is the session-based API, so to run the session we need to provide it with a configuration. So the configuration is AR world tracking configuration. So there are two types of configuration, depends on the device capability. If the device is having low capabilities or device with the less capabilities, we use AR session configuration. So that AR session configuration will only provide me with the device orientation information. But for the full device capable, means the device which are fully capable for AR like 6S and above, for those we use the AR world tracking configuration. So it will provide me the device orientation information, exact device position, and the third one, it will scene information. So these AR session features can be enabled or disabled through configuration. So now let's start with the geometries. So I don't need this, so I'm deleting this memory warning. So let's first, I want to keep it clean, so let's give it pragma mark. So there would be my all geometries. Okay, so I'm creating a function, so that will create a sphere, that will draw a sphere for me. Draw sphere. This is a function not taking any argument, and for this sphere I'll give you the complete description from the basic. And so I created a node, and I'm gonna add this node to my scene view. I'll explain everything. Node is nothing, that's actually a position in space. It has no shape, it has no geometry, it has no color. So, and what we are doing after that, we are adding that to the scene of the root node, and the root node is also having no shape, no color, no geometry, so it has nothing, but it has position. So the root node position is at the world origin. Like, I showed you the 3 line X, Y, and Z. The center is the world origin. So the position of this root node is at the world origin. So let's give this node a geometry. So node dot geometry equals to SCN. So we're gonna draw a sphere. So that's sphere, and we can init it with. So a sphere has only one property, that's radius. So let's give it radius of 5 centimeter. So we measure the distance, and so distance of all the unit of measurement is meter here. So if I write 0.1, it's 10 centimeter. If I write 0.01, it's a 1 centimeter. So if I'm writing 0.05, it's 5 centimeter. Okay, so I just created a sphere with a radius of 5 centimeter. Now just assign it a position. Position equals to, and if we see the position, what it is. Okay, this is strange. Give it position, and if you see the position is of type SCN vector 3. So SCN vector 3 is a three-dimensional vector, a vector which indicates the three axes. So let's say position equals to SCN vector 3 dot initialize it with, so there are different initializers. I want to initialize with a float value. So if initially I'm giving the position of 0, 0, 0, 0x, 0y, and 0, 0, and 0, z. So what I'm indicating, I'm telling this node to render itself at the world origin. So 0, 0, 0 is the world origin. So now let's call this method here, draw sphere, and let's see what will happen if I will render it. A circle with white color. So, but we have not given any color. So the default color of the geometry which will render is of white color. In the video, that the sphere is rendered right at the world origin, but we want it 30 centimeter back. So we can say that go and change this to 0.3. So this is rendering this sphere 30 centimeter behind the world origin. I run the application. So this is my sphere. So let's see the world origin. So this is my world origin. So if you see, my sphere is 30 centimeter behind the world origin. This is, so if we